Okay, in this video we're going to look at simplifying the square root of a whole number that is less than 100. Okay, the first thing that you guys need to really understand to do this is the following. If I have the square root of two numbers, a times b, that's the same as doing the square root of a separate from the square root of b. Okay, so if you have a square root of two numbers multiplied together inside of a square root, you can square root each of them separately and multiply together. That's the first big thing. The second big thing that I'm going to use to make your life a little bit easier is you need to recognize perfect square numbers. So your perfect squares. If you don't know your perfect squares, this is going to be really tricky for you. So if you look at the first 10 integers, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then you square them, 1 squared stays 1, 2 squared is 4, 3 squared is 9, so 1, 4, 9, 4 squared is 16, 5 squared is 25, 6 squared 36, 7 squared 49, 8 squared that's 64, 9 squared 81, and then 10 squared is 100. It's really, you need to know those numbers here. These are your perfect squares. And the reason why these are great to know is because if you square root any of those, you get the integer that generated it. So for example, let's take something super simple, 4, okay? If you see the square root of 4 anywhere, that answer is just 2. If you see the square root of 16, that is just 4. Okay, you guys probably know that. So if you know those things, it's going to be pretty easy. Let's show you an example. I'm going to show you 3 examples, okay? Example 1. If I gave you the square root of 20, the name of the game is this. If you have a number that you can't square root, like 20 is not one of these nice numbers I could just square root. It's not a perfect square. So you might think, man, I'm stuck, but not necessarily. If you look at 20, I can break that down into some numbers that multiply to 20. Now, I know 4 times 5 is 20. Now, I'm going to stop here because 4 is one of those nice perfect squares. So I can rewrite the square root of 20 as the square root of 4 times 5. Now, remember up here I was telling you if you have numbers multiplied together inside of a square root, you can square root them separately. So this is the same as the square root of 4 times the square root of 5. The square root of 4 is just the number 2. It's no longer in a square root. The square root of 5, I can't break that down into anything smaller, and I can't square root it, so it's just 2 times the square root of 5, and that would be my answer. I'm going to show you another way of doing it, just in case you didn't break it down this way. Let's say it was the same exact problem, the square root of 20, and let's say instead you said, oh, that's 2 times 10. Okay, you're right, it's 2 times 10, and you might think, well, how do I get to that same answer of 2 square root of 5? What you need to do is, if you can't break down any of those numbers any further, they're prime, and I would circle it. So like 2 is prime, I'm circling that, I'm stuck. But 10, I can break down into 2 times 5. And I can't break down 2, and I can't break down 5. So 20 is the same as a 2 times a 2 times a 5. Now, if you have a pair of the same factors, like a 2 times a 2 inside of a square root, what you're allowed to do is, like before, we can square root them all separately. The square root of 2 times the square root of 2 times the square root of 5. The great news is, anytime you multiply any of the same radicals together, you just get that inside back. So the square root of 2 times the square root of 2 is just 2 times the square root of 5. That's the same answer as I got here. So another thing to keep in mind is the square root of 4 is really the square root of 2 times the square root of 2, which is 2. So anytime, if you ever notice you have the same numbers inside, so like, let's say if I had the square root of a times the square root of a, if you have repeated factors inside, that's just going to give you that factor on the outside of the square root. Square root of a times a is just a. Just like the square root of 2 times 2 is just 2. Let's look at another example. Let's say I was doing the square root of 63. So 63, I know that, what is that? That's 9 times 7. Now, if I were you, I would stop right here because I know I can square root 9, right? That's one of my perfect squares. So this is the same as the square root of 9 times 7. I can square root the 9, and that's 3, but I can't square root that 7, so it's just 3 square root 7, and I'm done. If some of you guys don't catch that, you might still keep on going. So let's say you didn't catch that 9. Let's say you broke it into 9 times 7. You can make 9 into a 3 and a 3, and now you're stuck with a 3, and that's 7. So remember what I was saying up at the top. If you ever have repeated factors, like I have a 3 and a 3, it's repeated, I can take that 3 out, and I'm left with whatever's not repeated on the inside. So it'd be the same answer, 3 rad 7, just in a different way. Do one more example with you, like a tricky one. Let's say I have the square root of 32. Okay, lots of ways to break down 32. Let's just say, first thing that comes to mind is, I don't know, what, probably 4 times 8, right? You might say, ooh, 4. I can square root 4, right? The square root of 4 is 2, so I can take a 2 out, and then I'm left with 8. I can't square root 8 anymore. But you could break it down. There's actually more action inside of this 8. 8 is also 4 times 2, isn't it? And you can square root the 4 that's inside that 8. So if I rewrite this, I had the 2 that I broke down in front from the first 4 I square rooted. Now I have another 4 I can square root, but I can't square root that last 2 that's in the radical. So I'd copy down my 2, the square root of 4 becomes 2, and I'd be left with the square root of 2 inside. Whoa. Now these two jokers are outside of the square root. I can multiply them together, 2 times 2 being 4, and I'm left with the square root of 2 on the inside. Another way, same problem. Let's say you broke it down into 4 times 8 again. And let's just say you didn't notice square rooting 4. You could break 4 into 2 times 2, and you're stuck and you're stuck. 8 you can break down into 2 times 4, stuck with the 2, 4 into a 2 times a 2, and you're stuck and you're stuck. So 32 is really 1, 2, 3, 4, 5 2s, 2, 2, 2, 2, 2. There's 5 of them in there. Remember, pairs can leave. So I can pair those 2 up, that would be a 2. I can pair those 2 up, that would be another 2 on the outside. Then I'd be left with the square root of that last 2 remaining on the inside. Don't forget, 2 times 2 makes 4, and you're left with 2 on the inside. It's kind of a tricky topic. That's why I showed you a few different examples. Hopefully you took good notes. Look over it again, rewind, digest, ask questions, and good luck to you on this topic. Thanks for watching.